Okay, so the question said an object O of weight W supported by two inextensible cables A and B. Cable A is attached to the ceiling and cable B is attached to the wall as shown below. Okay? Tension in cable A is 1200 Newton. That is the force of A. It's the tension of that cable. It's the force from A. And the tension on cable B is unknown. So you don't know how much is TB or FA and FB. For instance, let's write here just for control. So FA, let's say, is 1200 Newton. That is given to you. And FB, you don't know how much is FB there. Okay? Ignore the mass of the cable. So the cables are massless. Cables don't have mass in this question. What is the net force acting on the object? That one, everyone should get it right. The object is not moving, is it? Therefore, it is zero. It's at equilibrium. The net force is equal to zero. We spoke about this one before. We say if the objects are not moving, it is at equilibrium. It's called static equilibrium, and the net force is equal to zero. Now draw a force diagram to show all the forces acting on the object. A force diagram, remember we spoke about that triangle. They don't want that triangle, they want a force diagram. Now a force diagram will be all the forces acting on that box. You will learn also about force diagram later on a little bit more in details. But if we come here, for example, let's represent on the same picture what forces are acting there. You have in this direction, this one is FA. You got that? Here, this is cable B. This one here will be FB. And pointing down, you will have weight. That is the force diagram. But let's do it here. Separated. Let's do it somewhere here. For instance, let's make this one to be the object. What forces are acting there? This one is FA. Now it's isolated. Now I'm taking the box out. Here you have in this direction FB. Let me perhaps take all this and move it there. And then pointing down, you have weight. This one is weight. Those are all the forces acting on that object. If you want to do the closed triangle, like you add in the forces, those three forces, you're going to add them tail to head. All you have to do is to add them with the same method you learned previously. On the tail of the first vector, on the head of the first vector, you place the tail of the second vector. So let's do it quickly, because it could be a problem. All right. So we draw first any vector. Let's start from here, and we draw there. This one is FA. You're supposed to have the angle accurate. All right. Here, you are going to have the axis, and I'm going to place right there. I'm going to place the tail of the second vector. In this case, will be FB. FB will be in that direction. That is FB. Okay. And then we have weight. If it's accurately done, it should supposed to be a closed triangle, because it's at equilibrium. The head of the last vector ends on the tail of the first vector you draw. If it's accurate, weight is supposed to be there, and it will form a closed triangle. If it's accurately done with the scales and measurement and so on, which is not the case here. Okay? So that's fine. No calculation. This is just drawing force diagram. Very easy. The problem starts, let's say the big problem, when you have to do calculations. They say calculate the tension in cable B. You don't have it. You have the tension in A. For this one, what I like to do is the axis, and draw on the axis the forces, because it will give me ideas of angles and components. You need to work with components. So I'm going to do here now the axis. Now I'm going to place here the force. you have to get the components of all those forces that are not on the axis. So we get here Fa in x, we get here Fb in x. Are you with me? And you are going to do the same for the y. You will get, maybe use another color, you will get on this side here Fa in y, and you will get here on this side Fb in y. Do you understand that? Now we need to learn the rule of the equilibrium. Everything that you have on the right, this must be equal to this. Nothing to say about that. That is equilibrium. Because they are in equilibrium, that side must be equal to this side. So if we write it here, Fa in x is equal to Fb in x. Why is that so? Because they are at equilibrium. And everything that we have on top must be equal to everything that we have at the bottom. What do we have on top? We have Fb in y, and we also have Fa in y. That is all we have on top. Is that correct? You can see it there. And all that must be equal to bottom. What is at the bottom? Just wait. This will give you the solution for all the calculations in this work. Okay? So now if we go back here, they say calculate the tension of B. So let's see what we have and what we don't have. We have Fa. Okay? And we have some angles. Let's find out the angle. Let's include the angles here, just for control. We have that 70. Therefore, this one here, let me get a color so you can see what I'm writing. This one here is 70 degrees. Is that correct? If you go here, look here, this side here, this one must be equal to that one, isn't it? Alternated between parallel. Is that correct? Exactly. And then this one must be equal to this one. This one is 40 there. I'm coming here to my free body diagram. This one is 40 degrees. Okay? So if we have this angle, now this is mathematics. This is pure math. Okay? You have to use the angle of 70. Let's use, for instance, the x-axis. Let's keep the x-axis using that one. Fb in x, how can you calculate this Fb in x? That side is here, isn't it? It's opposite 70. So if you say that this Fb in x is equal to Fb multiplied by sine 70 degrees, because it's the opposite side. According to the drawing here, that is opposite to the 70. And opposite you use sine. So I'm going to say here, that is for Fb, eh? How do you do it for Fa in x? In this case is the adjacent side to the 40. So Fa in x is equal to Fa cos 40 degrees. Then we have the way of calculating each of them. You have to always look at the angle. This is math. You cannot memorize things here like always is going to be like this. No, like this all the time. It depends on the angle. This is math. Okay? Now we can substitute those two here. Fa in x is Fa cos 40 degrees equal to Fb in x is Fb sine 70 degrees. Are you following me? And the rest is substitution. We are done. So the answer is 978,25 Newton. There we go. I didn't decide anything here. You have that right hand side must be equal to left hand side. that is a mass because it's at equilibrium. What do we have on the left-hand side? Left-hand side, let me see if I can show you here. Left-hand side, I have this one. What do I have on the right-hand side? That one. Now, why I decide sine of 70? Because it's the opposite to the 70. Alternatively, if you want to, you can calculate this angle 20 degrees. Okay? Thank you. You can use that 20, but I'm already doing double work. I'm already calculating an angle nobody asked me for. Now, if you use the 20, let's go down here, iso, you say then 20 becomes the adjacent. So it will be FB in X will also be FB cos 20 degrees. Let's see if we get the same answer. Now we go here and we do the same. The same as we're doing there, but instead of using sine 70, we use cos 20. So we have that FA in X is equal to FB in X. Are you with me? You can use any, but that is mathematics. Okay, now the question is going to ask you for calculate the magnitude of the weight. How do you calculate the weight? Everything that is on top equal to everything at the bottom. We did write it somewhere. There it is. There it is. You see? Real fast. We're going to the y-axis. Here is the adjacent to 70. Can you see that one? So it will be cos. Okay. So in this case we have that FB multiplied by, for FB is cos 70. Cos 70 plus FA will be, FA is adjacent, is a opposite, sine 40 is equal to W. Equal to W. And the rest is substitution. FB, how much we got? 978,25 cos 70 plus FA was 1,200 sine 40 degree, that will be equal to weight. How much you get? So we get here that the weight is equal to 1,105,84 Newton. That is the weight.